Hello everyone. Welcome back. Today, our topic of discussion is machine learning model optimization. Now, if you're familiar with machine learning or if you have heard the term, you know what the term model means or what model does. It is the heart of your machine learning code or program or whatever you call it. Model is the one that is responsible for performing the task that for which you're writing the code. Like it could be a classification, it could be a regression, any machine learning thing that you're trying to do, it's the model that does it. Like when you load the data sets, the training data sets, you train the model, you fit the model, and then you use the model to classify and you test the model. So it is very important that you optimize the model. Okay. So today we are going to talk about what is the meaning of optimization, how to do it, and more information about it. We will also see a Python code in the end which uses optimization techniques. All right. So imagine you're training the dog. Okay. So in this case, the dog is your model. Your goal is to teach it to sit, fetch, stay, basically teach the dog different tricks or teach the model different tasks. Model optimization is to figure out the best way to do it. See, a task can be done in multiple ways, but if you do it in the optimized way, you are using optimized resources. You're optimizing your resources because if you have to train a model, lots of resources are being used: electricity, computers, energy. If the model is effective, you make the best use of these resources. Okay. So model optimization is the process of making a machine learning model perform as good as possible on a specific task, because obviously the model is written for a task. It's about finding the best settings, and these settings are called as hyperparameters of the model. Okay, so it can make the most accurate predictions or classifications depending upon for which you have written the model. Okay, think of it as tuning the knobs on the radio to get the clearest signal. You know how in the next slide there's a picture, you had the radio with all the knobs, so you adjust the knobs so that the sound coming from the station is as clear as possible. What are the key ideas? The goal is to improve the model performance, the speed at which it learns, the accuracy with which it predicts. How? How do we do that? By adjusting the model's internal settings called as hyperparameters. So we don't change the type of dog that we are training. We try to change the trick, right? So let's say if we are training a golden retriever and we are trying to make the dog learn how to sit, and if it's not learning how to sit, it's not golden retriever's fault. It's not the dog's fault. It's the trainer's fault. Okay, so you don't change the dog, you change the technique. That means how we train it. Why? Because a poorly optimized model, of course, it can be inaccurate, slow, or both. A well optimized model is more reliable and more useful. So, and how hyperparameters are different from the parameters of the data? The parameters of the data define the data. The features, the parameters of the model are nothing but the features. Okay, so let's say, for example, if you're trying to identify which type of dog it is, so the height, the weight, the color of the hair, the patches, the shape of the eyes, those are the parameters, the features. Hyperparameter are very specific to a model, they are not general. Okay, so best model parameters, hyperparameter optimization picks the best hyperparameters. Okay. Hyperparameters are configured. See here, before we go ahead on the reading the slide, see here the knobs, and you had the station. I don't know if you guys remember. Like there used to be a thin line, like mostly it was a red color. And when you turned the knobs, it moved the line horizontally, like back and forth. Okay. And then you stopped where you heard the best sound. Okay. So that's what it was. That's what hyperparameters tuning is. You try different combinations and you pick the best one. Okay. So they are set by the data scientist or the programmers, whoever is writing the code. You set it. Okay. And it's not, the model does not learn on its own. So it's not the training data, it's the model parameters, like how you have a function, right? And or rather, if you say model, if assume model is a class, then when you construct a class, like in object oriented language, you certain parameters are, or rather what you call it as, certain members of the class, certain variables of the class have default value, but you can also pass it to a constructor, or you can also create an instance of a class by passing it to the constructor. So you don't use just the default values, but you use the values that are best suited for your scenario. Okay. So the hyperparameters is different to the parameters developed during machine learning training, such as data weight, which change the relative input to the training data. Okay. Hyperparameter optimization means machine learning model can solve the problem it was designed to solve as efficiently and effectively as possible. Now see here, this is a example in Python. So this is for the mm, flower classification, the iris data set, which is readily available. So you SPM support vector machine, from there you're importing the SVC model, and in the metrics you're importing the accuracy score, which we will be using to what do you call, find out how accurate the model is. And from model selection you're importing the train test split and also grid search CV. So we are going to see a in this code, we will see an example of this also. So basically all the imports, load the data set. So this is without the optimization, okay? Train and test, create the instance of the model. See, now here, whatever the SPC has default parameters initialized to, the model will have those. You fit the model, you predict using the test set, and you compute the accuracy score, okay? And you print it. Now, optimization. So this grid search, we are using it as the parameters or using for the optimization of the model. So right now, what in this particular example, for the SBC, we are going to use three different hyperparameters. C is the regularization parameter. Lower C means you're not overfitting the model. Higher C means you're trying to overfit the model. Kernel, the different type of tricks, okay, like the different training methods the model uses. Gamma, a parameter of the RBF, if the kernel is RBF, the gamma is how much influence a single training example has on the data. Again, it all depends upon how overfitting, underfitting the model is. So what you do is you define a dictionary. Okay, param grid is nothing but the dictionary. Basically, param grid is nothing but a variable name. What you are trying to do is create a dictionary. The parameter C can have these values. The parameter kernel can have these values. And the parameter gamma can have these values. Okay. And then instead of SVC, now you create an instance of grid SV, grid search SV. You pass it the simple model, you pass it the grid, And refit is equal to true, verbose, CV is cross-validation, and then grid search dot fit. So this is your new model. It's a grid search model. Okay. And then it will print the best search parameters. And now you test the optimized model accuracy score. Okay. Now here what happens is, this is a different example using grid search CV in logistic regression. This is a different Python example. This was SBC model. This is logistic regression model. Now see here, the parameters are different because it's a different class altogether. So when you create, normally in object-oriented programming, you create different classes. Each class has its own members, right? Which can be updated. Two classes may have some same members, but not all the same. If all the members, class members are the same, then they are nothing but just same class with two different names. So linear logistic regression has this problem solver and the C. Okay, now see, the C is common. It was there in the previous one also, in SPC also, and C is here also. But now there we had kernel. Here we have the solver. Again, we create grid search CV. We pass it the model. These are the iterations that we need to perform. You pass the grid, refit true. This is cross validation. And you fit the model, grid search model. You predict and you find the accuracy. So this was in short about the models. Okay. Now, what is the param grid? As I mentioned earlier, nothing, but it's a Python dictionary, right? Like key value, C with these values, kernel with these values, gamma with these values. So key value, key value, key values. Okay. It could be a single value or it could be an array of values. It depends upon the parameter that you're trying to hypertune or hyperparameter that you're trying to set. Okay. So grid search CV takes param grid as input and the model. And what it does, it generates, how it will train is, it'll take every combination and train the model on it. Okay. Like 0, 1 with 0, 1 with linear gamma scale, 0, 1 with linear auto, 0, 1 with linear gamma 0, 1. Like that, every combination it will take. 4 by 3 by 4, like all 48 combinations. It will train the model. It will create a new instance of the model because each parameter value is different. So 48 instances of this particular model will be created with these parameters or other hyperparameters, and then you train the model in using that one set. Then you again train the same model using this set. Then you again train the model using this set. Okay, and then evaluate the model's performance on each of this combination. So in the previous example, 48 instances of SPC will be created, and the best parameter combinations, the best accuracy score that we were computing, will be picked from those 48 combinations. Okay, so after trying all combinations, grid search CV identifies the combinations that achieves the best performance score. Okay, and then that is used for model training. So this is what all model optimization is about. So basically, model, nothing but in object-oriented programming language, you could call it as a class, or you can call it even as a function and the parameters of the function. Certain parameters have default values if you don't give it, but certain parameters, you can supply the value. You can give the value depending upon what you need. Okay, so now the question would be, how will I find which parameters value do I need to set? Or to begin with, what are the hyperparameters that are available to me? Okay, how do I know that I have to use C, or I have to use the kernel, or I have to use gamma, or for the previous one, I have to use C, like for uh, logistic regression, whether I have to use C or whether I have to use solver. How do I know this? That is there available in the API references. Okay, so when you go to the APIs, let me show you here. Here, so since we were learning SVC in the scikit-learn, so no matter from where the model you're picking up, the model provider has to give you the documentation. So for example, SVC here, the support vector machine, a support vector count, okay, or sorry, so support vector classification. So here you have C, kernel, there are so many other parameters. So if we just create an instance of SVC, these will be the values that the function, or you call it a function, or you call it a class, okay, is used. But if you want, you can override it, or you can create a grid and use all permutation combinations to see which permutation combination or which combination works the best. Okay. And remember, for every data set or every type of task, this combination would be different because the task is different, the data is different. So this is for SVC, the ones that we used. Here for logistic regression, penalty, dual, total, all those things, they are here. Okay. So now here again, let's say if you're using NUSC SVC model instead of SVC. So here you give the NU parameter, okay? The number of support vector classifications, number of support vectors. So NU stands for number of support vectors. So if you create an instance of NUSVC, and if you don't give this value, it's 0.05 value is used. So the default value is used. So these are the default values. For degree, it's 3. For kernel, it's RBF. For gamma, it's scale. So it's used. So let's say if it's linear SVC, it has these values. So basically, where you can find the information about the hyperparameters? By going through the API reference and going through the documentation. Okay, all right, just to recap, what are hyperparameters? The parameters that the model uses internally to create an instance of itself before trying to start training the data or learning the data and classifying the data or doing whatever task it's supposed to do. You find there is no fixed values for these hyperparameters, which works best in all given scenarios. It depends on your use case. It depends on your tasks. How can you find the value? Before you pick the model, before you choose the model, go to the model API documentation so that at least you are aware what are the values available, what are the hyperparameters available, and what are its different default values. It also gives you a detailed explanation of what each parameter is. So see, like for example, this intercept scaling, when fit intercept is true, the instant vector x becomes blah, 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 all these class weight, attributes, a lot of functions. There is also a function which is called as get params, which is there, get params, yeah, which returns all the parameters for this estimator or for this model. Okay, it'll return the get parameters of, like, if you want to know programmatically, but generally a good idea would be to go to the documentation. But if you want to know programmatically, there is a method called as get params. Okay, the parameter name mapped to their values. You can find it that way too. All right, hopefully you are a little bit, or your understanding about model optimization is a little bit clear after listening to this video. Feel free to ask any questions you have regarding any um, other topic that we spoke on this, or anything new that you would like the video on. Feel free to comment, like, subscribe. It's your choice. All right. Thank you all for your time. See you all again next time. Bye.